Chapter 21 is about organic chemistry, and in this first section we're going to talk about a specific type of organic compound called a hydrocarbon. First, let's talk about what organic chemistry is. Organic chemistry is the chemistry of compounds of carbon. All living things are composed of mostly organic compounds. They're what make you up, and you've learned about the basic building blocks for life in biology, like carbohydrates, nucleic acids, and lipids, and proteins. These are all examples of organic compounds, but there's lots and lots of different kinds of organic compounds. So the reason why there are so many different types of organic compounds is because of how carbon bonds. Carbon can form 4 covalent bonds with other carbon atoms. So here's an example. Here's an atom of carbon, and I can form bonds with another carbon atom. And I could just keep going on almost indefinitely. I could just keep going in a straight line of carbon atoms here. And this molecule would have 5 carbons in a row. But I could also have side chains. I can grow little side chains of carbon off the main chain here. So I could have a carbon going this way. So these lines here represent other bonds that carbon could form. So remember, carbon can form 4 bonds. So I can bond this carbon with this carbon. And these other bonds could be bonded to hydrogen, but they could also be bonded to other carbons. And I could just make pretty much an endless array of carbon molecules, carbon atoms bonded to other carbon atoms. You can go in mostly a straight line like this. You can go in ring patterns. There's double ring patterns. It's almost limitless how many different ways carbon can bond with itself. And that's what makes organic chemistry so complicated. So carbon atoms bond with the following characteristics. So as I said, there are 4 valence electrons of carbon, and it allows them to form 4 covalent bonds. These 4 single bonds of the carbon atom are spatially directed towards the corners of a regular tetrahedron. We saw tetrahedrons back in chapter 8 when we were drawing molecules. It's just an angle of about 109 degrees between each bonds, and they go in all 4 directions. As I said, carbon can share atoms with other carbon atoms, and 2 adjacent carbon atoms can share 1 to 3 pairs of electrons. So you can have a carbon-carbon single bond, or a double bond, or a triple bond. And the covalent bonding results in compounds that have the typical molecular characteristics. So let's just review what they would be for an organic molecule. So when we look at solubility of organic molecules, they have, the typical covalent properties, like they are nonpolar and they tend to dissolve in nonpolar solvents. When we look at their conductivity, they are usually non-electrolytes, which means they don't conduct electricity, but there are some examples of some weak electrolytes. And their melting points are generally really low, which makes organic compounds typically liquids or gases at room temperature. So you're often asked to draw structural formulas for organic compounds, and we'll be doing a lot of this practice in class, but this is what structural formulas look like. So this would be methane, CH4. So if I just wrote CH4, that would be its molecular formula, but if I draw it out with each atom, so there's my C in 1, 2, 3, 4 H's, and going in every possible angle like this, this would be a structural formula for methane. Now, it's important to note this is 2-dimensional. Whenever we draw structural formulas on the paper, they're 2-dimensional, but in reality, these things are 3-dimensional. We'll deal more with that in class and in lab. So here's another example of a structural formula. So this is a double bond between these 2 carbons here. And you can also have a triple bond, which would look like this. So one of the things that we often come in contact with in organic chemistry is the concept of isomers. So isomers are compounds that have the same molecular formula but different structure. So what do you think is going to happen to the number of possible isomers as the number of atoms in a molecule increase? You're going to get more of them because there's more ways to rearrange that formula of atoms into different arrangements. And this is the other reason why organic chemistry is so complicated. Let me show you an example. So here's a molecule of butane, C4H10. So I could draw it like this, and have 4 carbons in a row, and then have my hydrogens going off, 10 of them. Now notice that I just have lines going to nowhere. But these in organic chemistry is a shorthand way of writing hydrogen. So there's no such thing as an empty bond in chemistry. This bond here is actually a hydrogen atom, and so are the rest of these 9 here. Now, for sake of time in organic chemistry, it's okay to leave them blank. It's assumed that if you have a blank bond going to nowhere, that there's a hydrogen atom attached to it in organic chemistry. But anyway, this is C4H10. So that's one way to draw it, but I could also draw another way. I could draw 3 carbons in a row and then a carbon coming off the carbon in the middle. This is called a side chain. So there's 4 carbons, and here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So this is also C4H10. So it's the same formula, but a completely different compound. The one on the left would be called butane, and it would have a certain set of properties. And the one on the right would be called 2-methylpropane, which would have a completely different set of properties. So again, same formula, different name, different properties. This is, like I said, what makes organic chemistry pretty complicated. So in the world of organic compounds, there are a couple of different categories of types. And in this video, we're talking about hydrocarbons. A hydrocarbon is a compound that just contains only carbons and hydrogens, nothing else, hence the name hydrocarbon. Hydro for hydrogen, carbon for carbon. And in the world of hydrocarbons, there's 2 subcategories. There are saturated hydrocarbons. These are hydrocarbons that just have single bonds. And then there's unsaturated hydrocarbons. These are hydrocarbons that have double or triple bonds. And you just need to be able to recognize and classify them into these categories. So hydrocarbons fall under 3 categories called homologous series, and there is a table in your reference table called Table Q that has a nice summary of these homologous series for you to reference. So we'll be talking about these 3 kinds of homologous series in other videos, but they're called alkanes, alkenes, and alkynes. So we have the 3 names. Next, we have a general formula. This will tell you how to figure out the formula. So if I give you the number of carbon atoms in an alkane, all you have to do is double it and add 2 to get the number of hydrogen atoms. So you can figure out the formula using this general formula from this chart. They give you an example of how to name them. So they give an example for a hydrocarbon that has 2 carbons. So an alkane would be with 2 carbons would be named ethane. An alkene would be ethene, and an alkyne would be ethyne. And then they give you some example structural formulas. So they show you the drawings of what the alkanes, alkenes, and alkynes would look like structurally. So these things can be beneficial in answering various types of questions that you'll see. So in summary here, organic chemistry is the chemistry of carbon, and it's really a complex field of study due to the unlimited nature and ways that the carbon can bond to itself and other atoms. So this makes lots of different organic molecules. Organic molecules are all bonded with covalent bonds, so they're all nonmetals bonded to nonmetals, so that gives them the properties of molecular compounds, which you should know. And to draw an isomer of an organic compound, you just need to rearrange the structural formula, but the molecular formula must be the same. So sometimes you're asked to draw an isomer for an organic structure. You're basically just going to rearrange it and draw it in a different way. And remember, the bigger the molecule, the more possible isomers you could draw. Hydrocarbon is an organic compound that contains just hydrogen and carbon. In the world of hydrocarbons, there are saturated hydrocarbons that only have single bonds, and there's examples of those on Table Q. And then there's unsaturated hydrocarbons, which have double or triple bonds, and those examples are also on Table Q. So that's it for this video. In the next video, we're going to talk about how to draw some of these homologous series and how we represent them structurally.